Bismillahirrahmanirrahim. Assalamu alaikum. Today we are going to discuss about thin plate. So before going to analysis thin plate, first we have to know when a plate is treated as a thin plate. Here you see a plate of rectangular shape. Now we imposed the coordinate system. As it is a three-dimensional object, we have to impose a three-dimensional coordinate system like this. Now we notate the axis. This axis we will notate as x, this one y, and this one z. So if you see, x and y axis is on the plate and z is perpendicular with the plate. Okay, now we give the dimension of the plate. Along x-axis the dimension will be a, along y-axis the dimension will be b, and along z-axis the dimension or the thickness is h. So according to thumb rule, this plate only treated as a thin plate when both of these conditions are satisfied, this plate according to thumb rule is treated as a thin plate. But when we analyze this condition is not enough. We assume some other important properties of thin plate that have to be maintained during analysis. One of them is this. Here you see a shaded plane, and this plane is neutral plane. This is like neutral axis in beam, one-dimensional beam analysis. So this neutral plane always merges with the coordinate system. So here our coordinate system or coordinate axis, here our axis is x and y. That means x and y is merges with the neutral plane, and z is perpendicular with the neutral plane. So neutral plane is very important for analysis of thin plate. So here we can write down that. So this dimension we can say this is now h by 2, and this dimension also be the h by 2. Okay, so another thing, important thing, when we applied load on this plate, here you see the load. This is a surface load and this obviously distributed load. So we noted this as q, and this is function of x comma y, and q unit will be Newton per meter square, and this load on this plate is known as bending load. That means the plate have the capability to resist the bending load by bend its shape. So when its shape will be bent, it should be capable of resisting this bending load. Also this is an important criteria during the analysis of thin plate. Also here you see the thickness h will be constant throughout the plate. It will not be vary. Okay, so here you see the three dimension of this plate. Now we can see this is thin plate, h, B and E. Here H is comparatively very low or small compared to B and A. Okay, so we can, when we analyze this thin plate, we will treat it as plane stress problem. So in plane stress problems, the most important things is the plane of interest, which plane we are most interested. So here the plane of interest is this plane, the mid plane or the neutral plane, or the, we can say, if we erase it, we can say the xy plane or the plane perpendicular to the z axis. We will erase this. Okay, so in plane stress problem, we know that important things, loading factor is out of plane, stress is 0. That's mean here only available stress will be sigma x, sigma y and tau xy. If we draw sigma x, this will be like this, and sigma y along this direction, and the shear stress will be like this. And like this. Okay, so from equilibrium we know that tau xy equals to tau yx. Okay, so that's all for today. In the next video we will try to discuss about how we analyze this thin plate. So Allah Hafiz.